Units. Units are how we measure things. Okay. For the most part, we're probably used to the imperial, the English system, pounds, feet, seconds, and so on. Some of you may be familiar with what we call the CGS system, which is the centimeter, gram, second system. This is particularly common in chemistry and biological applications. We tend not to use this in physics. If you look at older references in physics, you oftentimes will see that. We tend not to use this anymore, even though this is our common parlance. And for the most part, we don't think about what is our mass in kilograms. We think about our weight in pounds. But we tend to use the MKS system, and pretty much with a few minor variations, usually because it's something more straight from the chemical biological fields, we will use the MKS system, which is the meter, the kilogram, and the second. Now, truthfully, sometimes you will hear folks say that, well, this is more accurate. No, accuracy is simply a matter of your equipment and how the measurement is made. It's not that this is more accurate. There are some advantages to using the MKS system, not just because of international commonality. One of the big ones is the fact that this is decimal based. So this is all base 10 for meter and kilogram. Second's still not. It's still a 5,000-year-old anachronism. The definition that we use for meter and the one we're redeveloping now for kilogram are simply based on historical purposes. And so there's nothing absolute or non-arbitrary about any of these measurements. The real advantages are the fact that they are a decimal system. Your prefixes. Make sure you learn your prefixes, especially the ones that are in increments of 1,000. And I'm going to rough out a diagram here. In your book, there's a table. So you've got your base. If you have things that are 10 to the third, and you notice I'm already using scientific notation. Okay, that is 1,000 times bigger. That is kilo. 10 to the sixth is mega. 10 to the ninth is giga. Sometimes it's pronounced giga. I don't know which is necessarily completely grammatically accurate, but I call it giga. And this 10 to the 12th is tera. Now, up until a few years ago, rarely did people ever talk about anything other than maybe the kilogram or a kilometer. Now, these are what I sometimes refer to as Walmart prefixes. If you go buy a flash drive, you're going to probably buy a 16, 32, or 64-bit, flash drive. If you're talking about hard drives, you're talking about terabytes or substantial fractions of terabytes. I refer to these as Walmart because you can, quite honestly, walk through Walmart and now hear people using these prefixes. On the smaller scale, we have milla, or milli. We have micro. We have nano. We have pico. And sometimes we actually will get down to the 10 to the minus 15th, which is femto. Now, there are other units above and below these, but these are the ones that we will mostly use. There's one other limited use here, which is centa. It's 10 to the 100th, or 100th, 10 to the minus 2. And typically that's only for centimeters, about the only place we'll use that. Now, in these prefixes, we have capital T, capital G, capital M, K, C, M, skipping micro for a second, N, P, and F. With the exception of kilo, the ones larger than the base are capital letters. The ones smaller than the base are lowercase. Kilo is just an exception. I have seen it written with a capital K, but the usual convention is lowercase. Now, I left out micro for a minute, deliberately. Because since lower and uppercase M have already been used, we do use the Greek letter mu and the lowercase Greek letter mu for micro. And I will provide you with a copy of the Greek alphabet. I don't expect you to memorize it, but it's nice to have it handy when suddenly you will hear me say a symbol or a letter in the Greek alphabet and you will see it written. And unit conversions, we'll practice these in a few minutes, but these move or translate from one set of measurement or scheme to another. It requires some form of equivalence. Statement. Now, that doesn't necessarily mean it's strictly equal to, and there are times specifically that we will say things are equivalent to when they are not really equal. So we will do this as we move forward.